Hi, everyone. Welcome to week 10 of the xAPI cohort. We only have 2 weeks left. This is going to be our last presentation session with just presenters. Next week's 11 and 12, we are doing our showcase. But for now, we're going to be focusing on visualizing learning data with xAPI and introduction to dashboards and analytics. This is with Jason Haag and Rob Chadwick with Veracity. And if you hadn't noticed, our next face-to-face conference is Learning in HR Tech Solutions, April 23rd through the 25th in Orlando. There is a register now button, which you can't click, obviously, but I will drop a link in chat so that you can get that. And as I understand, there might be a little like spinning wheel where you may qualify for some additional discounts for the conference. As a special thank you to the xAPI cohort, and of course, thanking Jason and Chad Udell here, they presented a session at one of our online conferences entitled xAPI Learning Analytics, Real World Examples, and Tool Evaluation Tips. Normally, this session is only available to online conference subscribers, but we have opened it up to all the members of the xAPI community and specifically to guild members. So if you are a guild member and you're part of this cohort, but you're not an online conference subscriber, that's okay. You can view this as long as you're a guild member. And just remember that membership is free at the guild. Our next online offering is Work Smarter, Not Harder. It occurs next week, April 10th and 11th. And I know there is a little bit of a overlap there with our next xAPI session, but we are recording both, so you can participate in one live and view the recording of the other. And I'll drop a link in chat too. And then, of course, as I alluded to, membership in the guild is free. If you're not a member of the guild, you should become one because there's a lot of free resources and a lot of things that are available to you, including discounts to our online conferences and in-person conferences. And lastly, next week, week 11 of the xAPI cohort, April 11th and April 18th, the last week of cohort, we're going to be doing what we call our xAPI showcase, where members of the cohort are going to give us the rundown of what they've learned during this cohort. Some have projects, some have just, this is what I did and this is what I learned. So that's great. And with that, I'm going to stop sharing, turn things over to Jason and Rob, and they'll give us their presentation. Now, neither one is going to be sharing a camera, and I will be making their presentation the only focus in the window for you, just so you know. And when you're ready, Jason, go ahead.
Thanks, Karen. Can you see my screen okay?
Yes, I can.
Okay, great. So welcome, everyone. This session focuses on the essentials of data visualization and analytics in the xAPI ecosystem. So we'll be highlighting the importance of measuring, collecting, and then interpreting learning and performance data. And we'll show tools and techniques for crafting insightful dashboards, and which help enable stakeholders to grasp learning outcomes and discern trends and make well-informed decisions. My name is Jason Haag. I'm joined by Rob Chadwick here, who's also a partner at Veracity, along with Tom Creighton and Jonathan Poltrak. We're all corporate alums of the ADL initiative. We spent many years there supporting xAPI and SCORM and other standards. I contributed to profiles specifically around xAPI. Rob built the ADL LRS conformance test suite amongst various other projects. And Rob also here is the lead engineer for Veracity Learning, our LRS product and analytics platform. So getting into the agenda here, this is what I'll cover today. I'll talk about measurement and data strategy, while Rob will really share his thoughts on and suggestions for thinking statistically when visualizing learning data, and also provide some examples for you. So yeah, there's a lot of options out there for authoring tools that generate xAPI data, but is the data truly representing the types of reports and analytics that you need? So first, I'd like to spend a little bit of time talking about measurement, evaluation, and modeling your xAPI data. It's extremely important for you to think about your measurement strategy, since what you measure will ultimately determine what you can do with visualizing the data. Last year, I don't know if you all have seen this, but I worked with Meg Fairchild, Meg Torrance of Torrance Learning on the first research report on the state of data and analytics in L&D. This is a great report, by the way, and it's available at this URL here on the screen. The report was focused on what types of things were people measuring, what types of analytics were they doing, the data formats, data sources, usages, and another key one is barriers to implementation. So, based on the results of the survey, a majority of our peers in L&D are simply reporting on completion scores, and they're often stuck on what the LMS provides. So, why is this? That's really the question on barriers to implementation and what that question revealed. There's lots of possible barriers to implementing analytics, but by and far the largest response at 65% was a lack of a defined measurement strategy. Organizations often want useful reports and analytics, but they lack quality data, which is typically the direct result of not having a defined measurement strategy. So, how do we fix this? Crafting your measurement strategy really should probably be the first step before you even start thinking about sending an xAPI statement to an LRS. I want to point out that our cohort team, as Karen mentioned earlier, will be presenting next week, where our cohort team is focused on this very topic of measurement and aligning it with your xAPI data strategy. We'll be sharing the resources that we developed on that team, and we also have a sample project we'll showcase where we defined the KPIs and the measures, and then how those translated into different types of xAPI statements we wanted to collect. Anyhow, I just wanted to plug that, as we'll be digging into that topic a little bit more next week at our presentation. So, what are some of the questions you can ask in the very beginning that will help inform your measurement strategy and the reasons for measuring? First, don't start with just asking what verbs you should use or even storing your first statement. Instead, here's some really non-technical strategic questions to think about. It's not a bad idea to start with an existing evaluation model or framework as a foundation. Good news is that you can start with really any framework that best suits your needs and just tweak it to your requirements. Secondly, you want to know who the stakeholders are, who are the decision makers. The executive leadership will really help you identify the business and reporting goals. Next, what are the business goals the learning solution is designed to support? Asking this question will help you identify the business impact measures. In other words, how will the solution you're developing really use to support the goals of the business? Next, what are the reporting goals and the requirements? And asking this question will help inform what and why you want to measure. For example, satisfaction, knowledge, retention, competence, and job performance. And next, you'll likely find the reasons for measuring will change over time as your learning analytics strategy matures. I really like this measurement maturity model from the Center for Talent Reporting. Most everyone starts with measuring to inform by getting counts of things or completions, and then eventually progressing to monitoring and evaluating and analyzing. And while the highest level of measurement is more focused on predictive and prescriptive analytics. So I mentioned using or tweaking an evaluation framework earlier is to meet your needs is really a good start. Here's some examples of the most popular frameworks in use today. There's, Kirkpatrick model, Phillips return on investment, talent development reporting principles framework, which is also now an ISO standard, and then LTEM. Really doesn't matter which framework you use. Just keep in mind, like, I think it's good to start because one of the things that all of these have in common is that each of the levels or tiers help you think more deeply about the things you should be measuring as part of your evaluation strategy. And you really need that type of strategic thinking in place from the very beginning to get the most out of your xAPI for visualizing your learning data. If you want to categorize measures, that's a good approach too, and makes it easier to map back to your evaluation strategy. Here's an example table I put together that shows, how the different frameworks line up. Um, Kirkpatrick model, TDRP, and LTEM. Really, in a nutshell, you could say that most, if not all, things you measure will generally fall under three kind of high-level categories: efficiency, effectiveness, and impact. So how do you figure out, oops, looks like I jumped ahead of the slide. So how do you figure out exactly what to measure? A good approach is to write out key performance indicators, which can then be turned into very specific strategic measures. KPIs are key performance indicators that communicate what is being measured in support of business goals in a nutshell. And so let's imagine an example scenario here. A CIO of a company must improve the level of cybersecurity preparedness of his in-house IT personnel in order to reduce the cost of recurring cybersecurity incidents, such as data breaches or cybersecurity attacks. And let's say that the goal is to increase the staff's knowledge and skills, so they're all certified by the end of the next fiscal year. And writing out KPIs with the SMART approach is also useful. Perhaps some of you have heard of this, but the SMART acronym stands for specific, measurable, achievable, relevant, and time bound, and helps you get really more specific about writing out those KPIs. Slides jumped ahead a little bit here. Sorry. Here are some example KPIs related to that goal. So, for example, we want to increase knowledge and skills, so we can measure how they perform in the course, or maybe simulations or some performance support content, and then the assessments. For the assessments, we can also set some targets, such as scoring 85% or higher and doing it within 3 months of completing the course. And this table illustrates how you might turn a KPI into a measure, and then the measures will inform what xAPI data you collect. I want to note that not all of your measures will always include or involve xAPI data. For example, if you want to see if cybersecurity incidents are decreasing as a result of your learning solutions, you'll need to get that incident data from somewhere else, obviously. So earlier I mentioned measures typically fall into those three categories. Here are some examples of efficiency measures. These are measures that help you provide insights related to quantity. They help you answer questions about how much or how long, and help inform and monitor things like utilization or volume or access and reach. And these types of measures, most of us in L&D are familiar with, because some of the basic efficiency measures are commonly available in LMSs, such as the number of course completions or the time spent in lessons or in courses. Here's some examples of effectiveness measures, which focus on learner reactions or perceptions, also knowledge assessments, knowledge transfer, and performance. Oops, jumped ahead. And here's some examples of impact measures, which are aligned to business results or outcomes. For example, impact on sales, impact on operations, impact on safety. You can imagine a lot of different ones depending on the type of company or organization. And so here's an example of visualizing effectiveness measures we defined for our KPI earlier. Increasing knowledge or passing assessments within 3 months. The measures can help you define what data you're going to end up collect, but they can also give you ideas for what graphs and other visualizations to create. So that's it. All I have on, just thinking about measurement and that whole strategy up front. And now I'd like to turn it over to Rob to talk about thinking statistically about the data and also some examples of graphs and dashboards and visualizations.
Okay, thanks, Jason. Hi, everybody. My name is Rob Chadwick. I'm an engineer at Veracity, and I'm going to show you, just some examples of the way that we crunch data.
You're not sharing your screen yet, Rob, too. Sorry.
Yeah, I know.
I just turned it over.
I know. I'm going to show you some examples of just kind of how we crunch data, how we think about the data is pretty important. And the general patterns that we follow when we are thinking about, telling stories with xAPI, trying to like pick out of these data streams information that is useful and actionable, right? Before we can do that, one of the things you're going to hear me speak about, just on and on, it just comes up all the time, is the xAPI data model. I know in this group, everyone has seen the subject, verb, object, and all of this. I'm not going to review the most basics of that, but I do want to just sort of foot stomp the concept of a property of an xAPI statement being like a dimension of data, right? So let's just review very quickly. I've got a statement viewer. There's lots of different statement viewers out there. They all look something like this, with an actor name and a verb, right, and an object. So Deborah Barbie, resumed improving neural networks, right? One of the things that's really important to note is when we're actually crunching this data, we don't tend to operate on the English language descriptions of things. This is an incredible point that really bears repeating. We are very interested in the unique identifiers of things, not the English language descriptions of things. So you're going to see me frequently pulling up object IDs. I'm sure in your previous sessions, we've talked about object ID. This is so important. It actually comes up a lot. Similar with the verb ID. The verb IDs tend to be somewhat less chaotic because they're largely standardized across the industry for the most part. But we still work with identifiers. Similar with actors. There's names. We like to kind of work over what's called the IFI in xAPI, which is either their email address or their account name, right? Account name uses some unique string. And one of the things I want to kind of belabor is the way that we consider a particular part of the xAPI data model to be like a dimension in the data. I mean, you can almost imagine an xAPI statement as this like multi-dimensional data point that like exists in this big space of 30 or 40 dimensions, right? Like the object dot definition dot name, right? Or let's do the context. Context, activities, grouping, 0 ID, right? Each of those different paths through the statement is a way that we can slice and bucket and filter xAPI data points. So having done that, let me zoom back out. The zooming in and zooming out gets all kind of silly. But let's do this. I'm just going to get like a new chart builder here and just start from scratch, right? So when I say that, we filter and slice, I use those words a little bit earlier, and I use them very deliberately because that's the basic algorithm that we use for doing lots of simple statistics over the xAPI data. Jason, you had a slide just earlier that showed lots of measures. And I'm not going to pull it back up, but if you look at it, you'll see it says the count of, the number of, the average of, the count of, how many, how much. It turns out that the raw information, the quantity of data, is a pretty good signal, right? There's a signal in there simply in how much data did we capture that meets a certain criteria. So let's look at that. Let me flip this over to like a time series chart, right? And you'll see this time series is not showing us much of any interest, right? Because I haven't filtered the data set. But you know, in traditional data sets, you actually see these big weekly and monthly patterns, right? My learning content just generated a lot less data over December. Well, I wonder why that is, right? It tends to happen. Not evident in this chart, by the way, but that comes up a lot, right? Also on weekends, you know, the learning data tends to follow the same basic patterns that any web metrics would for usage on weekends, right? There's a big dip on the weekends. In an xAPI data set, you could find signals in something as simple as daily counts of things. Let me just filter my series to a specific object ID. I told you earlier that I was going to just work on identifiers, and I can, right? So we can look at how much traffic is data science 6, or I guess 8 I clicked on, is it generating over time, right? That alone can give you some insights. Did we make the course available on a particular day and time? Did we make a social media post that drove people to our content? We want to come and see, did it have some kind of effect? Well, if, you know, on March, let's call that maybe, I don't know, the 1st of March, we made a social media post. Well, hey, that made a difference, right? There's a lot more traffic. These kinds of simple counts are powerful. You can get some kind of signal with them, but they can also be deceptive. For instance, maybe actually one person saw your social media site or your social media post in March and took the course, but for some technical reason they took it 10 times in a row, or whatever, or they left their computer on all night and it just kept sending data and data and data, but they weren't actually in front of the computer, right? Maybe your counts of things are highly offset by one person generating lots of data. Well, we can do a better job with the statistics, right? We don't have to just look at raw traffic. We can filter just a little bit more. Instead of simply looking at what's the total amount of data generated by Data Science 8, right? We can filter the data set further and say, look, I'm interested in specific types of events, right? Like initializations. This is a much better sense of what's going on. There's actually very few initializations of Data Science 8, but there are 3 times more at the beginning of March, right? So it isn't necessarily the case that our previous graph wasn't telling us what we wanted to know, but it may or may not have been confounded by individual people creating lots and lots of traffic. Looking at a particular event type rather than just the count of all traffic can give you a better sense of what's actually happening in the data set. Now, that does require you to have some understanding of the semantics of these events, right? I mean, we just happen to know ahead of time coming into this analysis that students can't really initialize 100 times during a session, right? They just initialize once. So that helps me to understand that there were 3 attempts, you know, on some date in March, rather than you know, well, I didn't say person. I'd be very careful there. Rather than one person sort of logging in 3 times. There's 3 different attempts. It's actually really relevant that, you know, I have not yet counted individual people. It's totally plausible that there's still just one person saw our social media post at the beginning of March and tried it 3 times, right? So that can go on to get more complex. Let's park that idea and do something different. We're going to come back to that. So, but before I get into sort of more complicated concepts, I want to do the basics. One of the things that you can get a lot of power out of is simply given some slice of the data set. And that's basically what I've done here, right? I'm looking at initializations of Data Science 8. Given some slice of the data set, what are the counts of different dimensions? Let me back out my filter. And instead of doing initializations of Data Science 8, let me pick something. Is that like the Data Science 3 looks like the biggest things. Let me just get a little bit more data. Doesn't really matter. And I'm not going to do a time series. I'm going to flip this over to a pie chart, and we'll look at we'll look at the counts of different values across a simple Boolean value. So let me show you what I mean by that. Let me get it together first before I explain it. All right, here we go. So you can get a lot of mileage out of filtering the data set and then counting the different values across a dimension. And that's exactly what I've done here. I'm looking at terminations of data science 3, and I just want a pie chart of the true and false spread across result success. So in your previous courses, I assume, I guess I don't know for sure, that we've introduced the xAPI's appropriate dimension path, right, for indicating success of something. And that's in result success. That gets used in lots of different ways in lots of different data sets, but for this data set, a successful termination is exactly equivalent to a pass, right? A successful complete termination, the complete is actually implicit, is a pass. So just like slicing the data set and then bucketing across the unique values on different dimensions, or I should say the unique values across a single dimension, can give you a valuable signal, right? Essentially, 80% of the terminations have a 0 in success. That's interesting, right? That may not actually be the right compute because I'm not entirely certain that all terminations are completions. You may be in suspended state. So let me, I mean, I'm kind of winging it here, but let me go ahead and add another filter layer and make sure we're looking at complete terminations. Completion is another property that is part of the result in an xAPI statement, right? There we go. Slightly different numbers, right? Still not great performance, but just over a quarter of complete terminations are successful, right? You actually notice, if you saw just a moment ago as I flipped through it, all incomplete terminations are not successful. That makes perfect sense, right? You're not done yet, so you can't be successful. You can get a lot of value out of these simple things. This particular example works really easily and somewhat simply because the ratios are all across these variables that are on the xAPI statement. The result complete, result success. Terminations always have them, so it's very easy to sort of just bucket up and divide and get yourself a graph. There are cases, I mean, this comes up all the time. There are cases where it's not quite so simple, right? You see a lot of content out in the world that has past and failed verbs rather than a single verb, right, which is terminated. With a Boolean result success, you see a lot of content that just says they passed the exam with a past verb, or they failed the exam with the failed verb. That's fine. We'll exercise the same basic idea, but we will like slice and bucket differently. So watch what I'm going to do. I'm going to add another filter layer to constrain us to specific verbs, right? So I'm really only interested in verbs, verb IDs. Remember I said we'll always do IDs that are either failed or, and let me show you how that works, is in the list of failed or passed, right, of data science 3. And I want to bucket it up by the verb ID again, right? So in this situation, there you go. In this situation, I am simply taking the data set, constraining it to all of the passes or the fails of JHU Data Science 3, right? and then I'm bucking it up by, was it a pass or was it a fail? In this situation, this graph renders a little bit nicer because it's not a raw true false. It's got a verb, and the verbs have nice English display names. You get the same basic data. It's actually not exactly the same as the termination I was showing before because it's different verbs, but it works out the same way. You can see though that we can get some valuable stats out of this. I'm doing this across a couple of different pass fails, very obvious, but there are like a myriad of different patterns in data where this same approach will work just as well. Something else that is useful, comes up a lot, is simple ratios. Let me show you how that works. Let me grab a different kind of tool here. Okay, great. This comes up all the time. People talk about pass ratios, right? You do have to think for just a minute about, in the xAPI data, how is that modeled, right? What's a pass ratio? You might imagine, the number of passes versus the number of fails. It's probably not the number that you really wanted, though, right? Because that means if there's an equivalent number of passes and fails, then the ratio is 1, right? It's probably not what you meant, right? You're probably more likely to be looking for the count of passes, right? I should say, yeah, the count of passes over the count of attempts. Now that gets interesting. What does it mean to attempt something in xAPI? I'll come back to a more complicated answer, but let me start by saying, in this data set, we have an initialized verb, which counts as, attempting. So you can do something as simple as divide the count of statements. I'm just going to do ID here for statements, right? The count of statements where the verb was passed. That's object ID. Sorry, let me do verb. Is it hiding down under my screen share thing? Because I don't see. Yeah, passed. There it is. Right. The count of passed over the count of not failed. Let me show you what I get if I do failed, because I said I'd do that earlier. So that's 76%, but this isn't really what you wanted to compute, right? You're interested in passes versus initializations. Now that shows me, you see it says average score. I just have to title my graph here. That's really not what I'm computing, right? There we go. If you're all paying close attention, you'll notice I've done something ridiculous though, which is this data set includes, passes and fails of lots of different things, right? I mean, maybe it's relevant to know the total number of passes divided by the total number of initializations, right? But that's not probably what you're looking for, right? That would just mean, if there were tons of different content in here, it wouldn't mean much anything. Let's make sure that we constrain the data set to one of these. I don't do data science 10 this time, right? And that's relevant for both of these. That is relevant for both of the, the numerator and the denominator. Let me go back and do this, add filter layer, and then I said data science 10, right? There we go, 50-50 pass fail for data science 10. Right? It's just, I'm sorry, 50-50 pass fail isn't quite the right thing, right? This doesn't account for the fact that some people who initialize may have no pass nor a fail, right? So these kinds of little caveats. I mean, you hear me caveating everything I say with this. Oh, actually, I just thought of something. Oh, actually, I just thought of something. That's kind of the art of this, is thinking of all those little details. This is the pass ratio, right? But the pass ratio and the pass fail ratio, as defined here, might not equal what you think they would equal. It might not be equivalent, because the pass-fail ratio is counting only people who have either passed or failed. But the passed attempted ratio may be counting people who are still in progress. Now, in a real data set in the real world, that might not matter, right? You might have, your denominator might be slightly bigger than the numerator, but for the most part, we expect at any given point in time, the majority of sessions have been completed. But it is absolutely something to think about when you're working with this data. So let's take a let me save this. Save my metric ratios. Call it pass ratio or something. I just kind of stick that on my dashboard here. So let's think about something else. Ratio of people passing is a good one. Pie charts across Booleans are easy. We did a time series earlier. I didn't save my time series. Let's go ahead and do the time series again, and note how you can do just a little bit of a simple comparison, right? The time series I was working on earlier. What are we doing? Add widget and then chart builder. Can't speak and work at the same time. Time series. The time series we were working on earlier was looking simply at the counts of things, and I was talking about how counts of things can be a useful signal. Let's go back to that because I mentioned that we would dig into that a little bit more. After having caveated the ratio example a lot, it's useful to go back and think about, what are we really counting when we're counting traffic? Let me add another layer to my filter and go back. Let's do data science 10 again. Is a note here. Oh, I only have 5 minutes left. Oh, I didn't realize that. Okay, let me go faster. Actually, we're getting a lot of value out of really foot stomping these basics. I'll go a little bit faster. One thing that you can do is, you don't have to pull a count. A count of data might not actually be all that valuable. Let me strike data science 10, look at the whole data set. Rather than counting all data, oftentimes you can get a lot better signal by counting what we call the cardinality, right? Which is the number of unique values across some dimension. So watch how I can do that. Set the value of each of these to the unique count of, not different scores, that doesn't make any sense, right? The unique count of identities. This is very interesting. You'll notice that this is a wildly different time series chart than I was looking at before, right? Prior to this, we were looking at how much total traffic is there. Now I'm looking at how many different people touched this data set on each day. That's a much, much, much better proxy for, how much use is my e-learning getting, right? Do we really care if one person used it for 2 hours and one person used it for 1 hour? And we say that's, better because there's more total usage? Nah, probably not. Knowing that more unique people, more unique agents, actor IDs, right, access something on each day, that's valuable, right? I mean, the other one has some value as well, but we find those kinds of things to be better. Something else I wanted to illustrate is histograms. Histograms are a pretty basic statistical technique, but they're pretty cool. Let's look at this. If you're looking at xAPI data and you have scores, using the techniques I described earlier, you might imagine that you want to get like a bar chart of all the different scores. Let me set that up because it isn't what you think it is, right? Well, we frequently see this. Show me a bar chart of the scores. Well, that's what this looks like, right? It looks like 24 people got 24 statements have a score of 0.05 or 054, whatever. That's interesting, right? And this does sometimes have value when you are looking at things like, a multiple choice question that can only be answered 25% correctly, 50% correctly, 75% correctly. Yeah, you can plot the counts of things, right? The counts of unique scores. But what you probably want is a metric called a histogram, right? You want to take all those different scores, stick them into buckets, right? And then count the number of scores that were between 0 and 0.1, 0.1 and 0.2, 0.2 and 0.3. And then you can start to see the bell curves that you'd normally expect, right? So that comes up a lot. People are not not quite getting very precise about what questions they're asking when they say, show me a bar chart of the scores, right? If there's anything to take away from this, it's that understanding the xAPI data model is really necessary to start getting to a solid statistic, right? What is it we're really trying to compute? I think the fail ratio is a very good example. What is it we mean when we say the pass fail or the fail ratio? Similarly, things like, how many people are using my content. That it turns out to be a little bit tricky to get to those kinds of answers from the data set if you don't really understand the data model. Now, the unique number of initializations, it's a good count. What if I initialize it 50 times? Should I count once or should I count 50 times? That really depends on what you meant by how many people, how many sessions, how many people, how many attempts. We make a lot of assumptions about those words that that make perfect sense when you're just speaking in English. And, me and Jason toss those words around all the time. But when it comes time to like build a dashboard or analyze the data or do a little bit of math, words like how many attempts turn out to be very, very wishy-washy, very wiggly. And you have to start digging into the xAPI data to quantify just precisely what do you mean by how many attempts. I think I have to wrap up, which is a shame because I could do this for a long time. We're covering just the most basic ideas about getting a little bit of signal from all the xAPI data that you have accumulated. But I hope some of this will be valuable to you as you're thinking about how you can get a signal from all that information, right? And I encourage you to think about xAPI like statement properties as dimensions, right? That can be filtered and sliced and bucketed, because that's how we do it. All right, Karen, thank you very much.
I'd like
for the opportunity.
I'd like to point out, though, that Rob has been using RASI's tooling for this, but the method of thinking about the data model really applies to any tooling and how you're bucketing and working with the data.
All right. Thank you so much. That was really informative. I know a lot of people, there were some questions in the chat here, and I think there was one in the Q&A. And while you were perhaps answering those in those particular areas, Meg Fairchild has an update for her team. So Meg, if you want to go ahead and let us know what's going on.
Sure. Thanks, Karen. I just wanted to do a quick update on where we're at with Team Test Your LMS. So we met at the beginning of cohort. If anyone remembers, we met, kind of oriented everybody to what we were planning to do, sent people off to do their testing, and now is the point where we're going to come back together and talk about what we learned, figure out if there's any next steps that we want to take in terms of like maybe pulling this together in a quick blog post or article or something that we can share with the rest of the community. So I have posted a poll in the Slack channel for Team Test Your LMS with Torrance Learning. And so anybody who wants to join us, we're going to try to get together sometime next week. I've put 3 different options. Please answer the poll and I will choose a date and a time and we will meet on Teams or Zoom or one of those platforms. So that's it for me.
All right. Thank you so much, Meg. And thanks to Jason and Rob for giving us that great demonstration. And don't forget, everyone, next week will be the first week of our 2-week showcase where we will have our cohort team members come and recap for you this wonderful cohort. So with that, I'm going to thank you all for being here today, and we'll see you next week. Bye, everyone.